Hello, this is Mr. V. I want to welcome you to the Exam 1 review. It is done in 3 parts, so be sure to check out Part 1, Part 2, and Part 3. What I've done in this particular video is I've solved some linear equations. I've also solved some quadratic equations, solved some inequalities, absolute value equations, absolute value inequalities, and I've done a little bit of some things with complex numbers. My goal is that this helps you out so that you can be prepared for the exam. Alrighty then, let's get to work. Alrighty then, let's get this show started. We are going to go through the exam 1 test review, and hopefully we'll make this as painless as possible. We got 25 questions to go through, so let's go ahead and get started, okay? It seems like in the first few questions, we're solving some linear equations. So let's see what happens here. So I'm going to give you some strategies or more like tips of what I will do in this situation. And then hopefully once you take the exam, then you can go ahead and maybe in a way replicate this these techniques. All right, let's get the show on the road. All right, so out of the first question, I am noticing that we need to do some distribution. So let me highlight that. A distribution here, distribution here, distribution here, and distribution there. Okay, so when I'm saying that, I'm saying we just need to multiply. So let's write over here. 4 times W will be 4W. 4 times -4, that will be -16 or -16. And then we have a -4. That's equal to negative times a negative is positive. 2 times 2 is 4. So we have 4W. -2 times minus 14. And then we have a -4W. Before I try to combine things from one side to the other, let's combine things on this side first. Then we'll do combining some terms on this side, and then we'll play the game. All right, so we have 4W. These two terms do combine to get -20. Is equal to, that goes away, and we have -14. The whole idea is to isolate the variable, so we're going to add 20 on both sides. We get that 4W is equal to 6. After dividing by 4, we get that W is equal to 6/4, or better yet, these two numbers are divisible by 2. So divide by 2, whoops, divide by 2, and we get 3/2. Alrighty then, moving on. For the second example, it seems like we're solving an equation, but we got some denominators here, okay? So let me rewrite this like so. I would like to write 5x over 1 minus 1/6 is equal to -1/2x minus 5/3. So what I like to do in these type of situations, not that I am afraid of fractions, but most of us do not like dealing with fractions. So I am going to find a least common multiple for the denominators. And what that allows us to do is to rewrite the example without the need of fractions. So let's see. Here are the denominators: 1, 6, 2, and 3. The least common multiple out of these numbers will be 6. So I want to make sure that every denominator here is 6. So I'm going to multiply this by 6. But if I do so here, I must also do it up there. Right here, 6, that's already 6. I'm going to leave that alone. But this right here, I'm going to multiply by 3. And so upstairs, multiply by 2. Also do that upstairs. Notice that when I rewrite this example, I am going to rewrite it without the need of denominators. 6 times 5, 30, minus 1 is equal to, this is 3 times negative 1, which is negative 3x. And then we have a minus 10. Notice that once we do that, once all the denominators are exactly the same, there is no need for more denominators, okay? All right, let's combine some like terms. Oh, nothing here, nothing here. Okay, there was nothing to combine on the left, nothing to combine on the right. So I prefer to put my x's on the left. It is it is a good practice. It is a common practice, but it's really helpful when we solve inequalities, okay? So I'm adding 3. Here we get 33x minus 1 is equal to negative 10. Add 1. Add 1. We get 33x is equal to negative 9. Divide by 33. Again, the whole idea of solving an equation is to isolate the variable. So we get x is equal to negative 9 over 33. Both of these numbers are divisible by 3. And so we get negative 3 over 11. Nothing wrong with getting a fraction for an answer, okay? Alrighty then, let's move on to the next set of examples. And let's stay right here with number 3. For each equation, choose the statement that describes its solution. So when we solve equations, it is very common to find an answer. But in some situations, we may not find an answer. We might find no solution, or we could also find way too many solutions. So let's go through these 2 examples, and then if we need to, we'll go ahead and refer to the ones we did before, okay? So let's see. Let me rewrite this here. So we have 4 multiplying this quantity minus 6v is equal to negative 2 times v plus 6. One thing that I'm noticing here is the distribution. Okay, notice how this 4 distributes over what's inside of this parentheses, while negative 2 distributes what's inside of this parentheses. And when I say the word distributes, I am very much implying multiplication. So we get 4v minus 12 minus 6v is equal to negative 2v minus 12. Again, I'm multiplying, okay? Combine like terms. Oh, I see some terms that could be combined together. This set of v's with this set of v's, I notice that there's more negatives, so we have negative 2v's minus 12 is equal to negative 2v minus 12. Uh-oh, I am recognizing that the left is just like the right, but I will just continue and see what's up. Very common practice to move my variables to the left. This is gone. Oh no, so is this. Negative 12 equals negative 12. Okay, what can we say about that? Last time I checked, this number, negative 12, was equal to negative 12. This is an identity. And so what does that mean? Therefore, this equation has solution set all real numbers. So this example happens to be an identity. So let me just write the word here, identity. It is an identity, and therefore, since it is an identity, its solution set is all real numbers. How do we know it's an identity? As we went through the algebra here, we recognize that we lost the variables altogether. There was no more variables. But we looked at this statement and let's see if I can highlight it. Yes. We looked at this. Oh, that was not a highlighter. Okay, it is what it is. We looked at this statement and we recognize that this is true. Negative 12 does equal to negative 12. Therefore, it is an identity. And oh gosh, I'll just move on to the next example. Okay, is an identity, all real numbers. Alrighty, then let's look at the second example here. We got 5 times the quantity 2 minus y is equal to 2 times the quantity y plus 1. This is my distribution. All right, we get 10 minus 5y minus y is equal to 2y plus 1. So let's combine like terms. Here's a set of y's. Here's another set of y's. We get negative and a negative makes more negative, negative 6y. 2y plus 1, okay. Again, it is common practice to put all these y's on the same side, commonly on the left side. And we have in total, let's see, 10 minus 8y is equal to 1. One thing that I noticed that is different from the previous example is that we did not lose the y's. So I have a strange feeling that we're going to find an answer since we didn't lose the variable. Okay, minus 10, negative 8y is equal to negative 9. Divide by negative 8, and we get, I'm going to write this up here, negative divided by negative is positive. And that is the best that we could do for this fraction. Okay, so this is an example. Okay, this is an example of an equation that is referred to as conditional. Equations that are conditional have a solution, or maybe I should probably use the word unique. The answer might be one solution, or it might be 2 solutions, 3 solutions, but the solutions are unique. Those are referred to as conditional equations. The first 2 examples were examples of conditional equations because we found the answer to be this and we found the answer to be that. In this example, we lost the variable altogether. So we analyzed the final statement. After analyzing, and I'm looking at the highlight here, that is a true statement. However, if that statement would have been false, for example, 0 equals negative 12, this is false, and therefore, if that would have been the situation, therefore this would have had no solution. These are referred to as contradictions. So in this course, okay, we're going to solve a lot of conditional equations. And in some situations, we are likely to run into some identities, and we're likely to run into some contradictions. Okay? Alrighty then. So I cannot guarantee that there will be exactly like this on the exam, but I just wanted to kind of point out that maybe on the exam there will be a contradiction rather than an identity, or maybe instead of this being a conditional, it would have been a contradiction. You know what I'm trying to say, right? So let's move on to the next example because we got 25 questions to go through. Alrighty then, I think I need to change my ink here. There we go. All right, let's get busy. We have that we need to solve for b. So let me do this work here. Again, this looks very linear-ish, and so I am going to take away c from both sides. A minus c is equal to 7 times b. What does it take to get b by itself? Divide by 7, divide by 7, and therefore, okay, A minus C, everything divided by 7 will be equal to B. Okay? If you prefer to write it in this form, that's perfectly okay. Okay? As long as we are saying that B equals that. Okay? All right, let me erase that because I don't want to take too much time. Or here we go. Or I'm in like more space. I want it to be clean and things like that. So I don't know. For some reason, I feel like writing it over here again. All right, moving on to the next example. Ooh, we're trying to solve for Z. Okay, here's Z. But we got fractions. And I mentioned that earlier that there's something about fractions. I'm not saying that they're bad. I'm not saying that at all. But what I'm saying is that there's a lot of us that do not feel comfortable solving equations that involve fractions. So what is your technique? Meaning me. This is my technique for clearing fractions. The textbook does it a different way, especially if you took the notes. You'll see that they do something a little bit different, but overall, again, it's the same job. Okay, it is the same job. What is the least common multiple of the denominators? Well, here's 1, here's Z, and here's 4. The least common multiple is going to be 4Z. In other words, I couldn't really think of a number or a quantity. So what was the easiest thing for me to do? Multiply, multiply. Okay. And after multiplying these denominators, we then saw that a least common multiple is 4Z. Okay. Or at least, let me say it like this, a common multiple will be the product of these denominators. All right. Moving on here because we don't want to confuse anybody. So let's change the ink because we're going to be writing some things. So let's see. We're going to multiply by 4Z because we want all of these denominators to be exactly the same. What do I need to multiply Z so that it looks like 4Z? You got it. Times 4. What do we need to multiply this for to make it equal to 4Z? You got it. Times Z. So what happens now, Mr. V? Well, there will be no more denominators. There will be no more fractions. Check this out. First of all, I forgot to multiply. So let's do that. 4 times 2 is 8. So we have AZs plus 40 is equal to 3Z. Okay. It is common practice to move the variables to the left, but in this case, it seems almost natural the Z's on the right side, okay, to avoid too many movements. And then dividing by -5, 40. Okay, first of all, let me get this right. A positive divided by a negative is negative. 40 divided by 5 is 8. So, oh, this is a conditional. This is a conditional because we found an answer. And by the way, this answer is valid because, well, the only number that this cannot be is 0. So we're okay. We're okay. Alrighty then, moving on to number 6. Number 6, more fractions, but that's okay. Now you've seen my technique that I use to make sure that we don't have any fractions as we move forward, okay? So what I'm going to find is the least common multiple. And let me just kind of, let's see if I could get away with doing something like this. Let's see. I'm gonna try this out. I'm gonna write this like this. That's a 1. Let's not forget. I'm gonna do this. Okay, I'm gonna do this. 1 over 1. Yes. Alrighty then. What are the denominators? The denominator is this and that, and also 1. But there's something here that is catching my eye. Okay, it's catching my eye. I feel like we can factor out a 2. we can write this like 2 times v minus 2. Okay, why do that? Do that because, wait a minute, Jose, that's v minus 2. This also has a v minus 2. What does this denominator have that this one doesn't? You're right, the times 2. So the times 2. So what is the least common multiple? Let me actually write that down. The least common multiple will be 2 times v minus 2. This already has the v minus 2. So I'm multiplying by 2. Let me clean that out because that doesn't look clean at all. Notice that this denominator already has the v minus 2. It just needs the times 2. So let's write that on there. What does this denominator need? It needs the 2 times v minus 2, okay? And it's the 2, the v minus 2. So what happens next? No more denominators. Let me do this. I know it's going to look a little funky and yucky. No more denominators. No more. No more. So we have 6 is equal to, I think that's a negative. Oh, wait, that's a negative 6. Look at that. Okay. Negative 6 plus, let's take care of this business, 2v minus 4. Combining like terms, we get, okay, we get this and that. That becomes negative 10 plus 2v. Okay, so plus 10, we get 4 is equal to 2v. Dividing by 2, we get that 2 is equal to v. I feel very much accomplished. But maybe I need to check whether or not, just like I did before, whether or not this actually makes sense. So let me erase all of this. Erase all of this because we already did the work, and you can go back and rewind if you need to, okay? If v is equal to 2, that makes that denominator equal to 0. Even worse, it makes this denominator equal to 0. And that's a double whammy, or it was a whammy to begin with. So even though we were able to find a solution, we need to reject it because it makes one, or even worse, many denominators equal to 0. So even though we were able to find 2, we have to say that this example has no solution. Okay, that was not the case on the previous example. Okay, let's just rewind the tape. We found that the answer for this example was negative 8, but negative 8 does not make this denominator equal to 0. So it was accepted. In this particular example, we found that v was equal to 2, but when we checked, it makes this denominator equal to 0. Even worse, it makes this one also equal to 0. It must be rejected, and unfortunately, we have no solution. Alrighty then, it's 7. 7 and 8. Let's do 7 and 8 together. Okay. Let me give you my strategy on this type of examples. At this point in time, you have already learned about combining like terms. I'm not trying to memorize any formulas here. I just do the things, okay? I distribute the negative into that parentheses. And then I combine like terms, which is there's negative 3i's. There's 1i there. So after combining that, we get negative 2i's. Minus 4. Okay. The instruction is to write this complex number in standard form. What does that mean? A plus bi. First is the real number, and then second is the imaginary number. So to write the answer correctly here will be -4 minus 2i. The real is first and then the imaginary. Okay? All right, in the second example, they want us to multiply. Okay, I'll give you some hints as I go through this particular example. And I'm going to use the technique of foiling here. Okay, so I'm multiplying. So I'm using the foiling technique. Works perfectly in this example. So the first, then the outer terms, we get positive 2i squared. Wait, no, what am I saying? No. That's not what I'm saying. Okay. I know what I'm doing, but I think I messed up the acronym. Okay. First, outers. Okay, outers. I'm still doing the same thing, but I think I don't know why I'm kind of going like crazy. Outers, inners. Okay. Wait, what am I doing? For some reason I'm not remembering the acronym FOIL. I know first, outer, inner, last, but oh, I think okay. So I know how to multiply this is I'm trying to use the word FOIL. So there we go. Outers. That's what they mean by outers. Okay. Okay, that will be -12. I was trying to show you a technique and I probably screwed all that up over there. Okay, here we go. Now is the inner terms. The inner terms. That will be -4i. And now the last terms. The last terms. We get positive 2i squared. All righty then. So we got 24. Right here, these two terms do combine together. This one's right here. Okay, so we get -16i. But what happens here? And let me try to highlight it. What happens here? What happens here? By definition, I squared is equal to -1. Okay? So therefore, what the I squared does, it switches the sign on that +2 to a -2. That's it. 24 minus 2 is 22 minus 16i. And of course, this is in standard form. The real, and then the imaginary part last. Alrighty then. Hopefully I didn't screw that up. And let's move on to the next set of examples. Divide, okay, divide. When we're dividing complex numbers, it's going to feel very much like asking you to multiply. Check this out. If we have a complex number a plus bi, its conjugate is a minus bi. Why is that useful? Because somewhere along the lines and throughout history, and especially in mathematics, the history of mathematics, it was determined or a consensus was made that fractions where the denominator is an complex number, that necessarily wasn't acceptable. Okay, so we don't usually write fractions that have denominators as complex numbers. So how to fix that? To fix that, we multiply by the denominator. Oh, that's horrible. To fix that, we multiply. To fix that, we multiply by the conjugate of the denominator. And so here we have 4 minus I, and we're going to multiply by that. So as I said earlier, it feels very much like you are, or like we are trying to do something multiplying complex numbers. Let's move quickly through this. We get -24. We get 6i, we get positive 4i, and then we get, wait a minute, I messed that up again. What in the world is wrong with me? Rewind the tape, right? Rewind the tape. We got positive 6i, then we get here. Let me delete this before I do that, okay? Then we get here, we get negative 16i, and now we get positive 4i squared. My gosh. Down here, hopefully I won't screw it up this time. 36. We get this, we get negative 24i. Here, well, that's a positive, my friend. Negative times a negative. Here we get negative 24i. And then here we get negative 16i squared. Alrighty then, let's see. Let's clean this up. Let's play cleanup. First, let me fix this before I make a mistake. So notice that I highlighted, and instead of having positive 4, I write negative 4. I took care of that. So we get negative 28. And then this is 6 minus 16, which is negative 10i. Here, same thing. Before I forget, let me go ahead and highlight that. Make this a positive 16. Cross that out. 36 plus 16, that's equal to, what is it, 52. And then 24 and negative 24i's cancel each other out. Okay, so this is what we got, ladies and gents. We have negative 28 divided by 52 minus 10i over 52. Okay. Now, this needs to be simplified. So let's do this slowly, okay? They're both divisible by 2. So we get 14 over 26. They're both divisible by 2. We get 7 over 13. So we get negative 7 over 13. Minus, these are both divisible by 2. We get 5 and 26. 5i over 26. And notice that in this case, this is the real, and that's the those complex numbers in standard form. Alrighty then. I don't know. It seems like I'm having network connection issues. I don't know what that means. I'm just going to close that out and hope that this is recording nicely. Alrighty then. Why don't we go ahead and do this? We solved a lot of linear stuff here. We talked about complex numbers. Let's call it that this video will cover examples from 1 through 9. Okay, examples 1 through 9. And so I do want you to come back to the next video so that you can see, and let's see if I can do this correctly. Let's see if I come back to my next video, okay, to check out the next set of examples. All right, see you in the next video.